Hello children, welcome to my channel, and today we are going to talk about a very important topic, and that is dissipation of energy in the form of heat in the electrical circuit. For this I will start from the place where I had ended the last lecture, and that was based upon potential difference. So potential difference between the 2 points in the electrical circuit is actually the work done in carrying that unit positive charge from one point to the another in the electrical circuit, right? So if I need to calculate the total amount of work done, that is the total number of joules spent in carrying q amount of charge, I must cross multiply here with V, that is the potential difference between which the circuit is kept, right? This will give me the total number of joules spent to move q amount of charge. Now children, in order to bring the concept of heat or energy dissipated in the form of heat, we must understand that during transmission most amount of work done, that is mostly the work done, is realized or is spent or is converted in the form of heat during transmission, right? So we can aptly write that work done is actually equal to energy transferred in the form of heat, right? And that will give me V into Q. So this H is a substitute for work done. Here H will represent approximately the same number of joules which were spent in causing the movement of the q amount of charge from one point to the another in the electrical circuit. Now if these number of joules are converted mostly significantly in the amount of in the heat energy, then I can clearly substitute work done with heat, right? So this will give me H is equals to V into Q. Now by using the law of current, that is current is equals to flow of charge per unit time in a specified direction, I can write Q as product of IT, because current is equals to the quotient between Q and T, right? Charge and time. So this gives me expression number 2. Now if I smartly use Ohm's law here and substitute V as IR, then I will get IR into IT. Now I can suffice by writing I²Rt. So this was what James Prescott Joule worked upon to find the relationship between current, resistance, time and heat energy, heat produced or energy spent in the form of heat in the electrical circuit, right, in the early 19th century. Thank you children.